All right, so a couple things to keep in mind. Here's the schedule up until our next our next test. Okay, so I will not be here Monday. So what I'm going to do today is teach you kind of both today's material and Monday's material, and it shouldn't be too bad because it's just pattern stuff. It's arithmetic, which is adding by the same number each time, and geometric, which is multiplying by the same number every time. So we'll hit that all today. Monday, I'll give you the homework assignment tonight and the review sheet for the test as well tonight. Monday, you'll have an opportunity to work on basically any of those things. The review sheet, if nothing else, the review sheet, the homeworks, if you haven't done any of those homeworks, and, well, the homework for tonight, I guess, and then the homework for any night, I guess, and then the problem set as well. So those three things will be kind of like what your assignments will be for Monday, okay? So good news for you procrastinators, okay? And then Tuesday, I'll come back. We will do our review day that day, okay? Answer any questions you might have. And then Wednesday is the test, okay? The test is going to cover solving trig equations. It's kind of like a weird hodgepodge. Solving trig equations, the law of sines, law of cosines, and then this sequences, arithmetic sequences in series and geometric sequences in series as well, okay? So that is the the gist of what's happening. So up till Wednesday. All right. So that being said, let's get into what we're going to do today here. All right. First thing we're going to talk about are sequences. Okay. And we're going to hit both arithmetic sequences and geometric sequences, and then we'll talk about series, which are similar but not the same. Okay. So sequences. Okay. So a sequence is kind of just like a list of numbers in a particular pattern. So we kind of were doing some sequences there for the warm-up and stuff like that. And of course, some sequences have like a regular kind of pattern, or like we categorize them, right? And so one category of sequences that we're going to need to be familiar with is arithmetic, okay, or arithmetic sequences. Okay. And basically, it's just a sequence of numbers whose difference between consecutive terms is the same. Sequence of numbers whose difference between consecutive terms is the same. Okay, so for example, 3, 7, 11, 15. Is the sequence, all right, is the sequence, is that arithmetic? Is the difference between consecutive terms the same? Okay, yes, what's the difference? Okay, so right, it's 4, a difference of 4, right? Each time we're adding 4 to get to the next term there. Okay, so in arithmetic sequences, that common difference, it's a shared difference, right? 7 minus 3 is 4, 11 minus 7 is 4, 15 minus 11 is 4, and so we call that the common difference. That 4 has a name. It's called the common difference. Okay. If you ever want to find the common difference, it's just a sub n plus 1 minus a sub n. Okay. You take the next consecutive term, subtract the previous term. Okay, that's what that means. Like a sub n, that's going to be some term in your sequence. A sub n plus 1, that's going to be like the next term. So it's the next term minus the original term. Okay, that's the idea there, to get that common difference if you ever need to like calculate. I mean, it's just really, but 7 minus 3, 11 minus 7. That formula might be too, complicated for what you're really just doing there. Okay, so we have a formula. This one you will not be responsible for memorizing. To find the nth term of an arithmetic sequence. Right, and that nth idea, right, is that saying, you know, if I wanted to find the 100th term in this sequence, or if I wanted to find the 1000th term in this sequence, I could just keep adding 4 until I get to the 1000th term, but obviously that's going to take a really long time. So instead, we use this formula here. The nth term is equal to the first term plus the number of the term minus 1 times the common difference. Okay, so again, that's the nth term. Okay, and all I'll be giving you is the formula. I won't tell you what those things mean, so you don't need to remember. A sub n means the nth term. A sub 1 means the first term. N means the number of the term. D means the common difference. Okay. They're kind of self-explanatory when you just see them. Okay. Kind of, I guess I put that in air quotes too, right? Air quotes. Okay, so let's apply that to our sequence up here. So let's write an equation for the nth term of the above sequence. Okay, so let's use this sequence from up here that we just talked about. Alright, so again our formula is a sub n plus a sub n equals a sub 1 plus n minus 1 times our common difference. So we're writing an equation for the nth term. We don't know what it is, so that's what we're going to leave that. That's like our y basically there. Okay. What's our a sub 1 in this case? 3, right? It's the first term. Yep, 3 plus, and then n minus 1. Okay, because you don't know the number of our terms, we have to leave that as n. Okay. And then what's our common difference? 4. Okay. And so you can, if you want, you can leave your formula just like that and say, okay, there it is. And so if I wanted to find the 100th term, you know, if I wanted to find the 100th term, then I would write, bless you, a sub 100 to indicate this is going to be the 100th term, and that'll equal 3 plus 100 minus 1 times 4. Okay. And so then, you know, 100 minus 1 is 99. 99 times 4 is 396. Plus 3 would be 399. I think I did that right. 400 minus 4, 396 plus 3. Yeah. Okay. Right. So that's how you could kind of use that. If you want, you can simplify this formula down. You know, you can. So we distribute the 4 there. We get 3 plus 4n minus 4. And so it's really just 4n minus 1. Okay. If we were to graph this, what would this look like? If we were to graph this formula here, what would it look like? If we had like y equals 4x minus 1, what would that be when we graphed it? And so it'd be a line, right? And that's all it is. Yeah, it's a line. Okay, this is a linear relationship. This is a linear relationship, right? This is a linear relationship that we have here, okay, in an arithmetic sequence, right? Just like the slope, right? Every, you know, for the slope, that's kind of like your rate of change. Okay, you're like adding that same amount each time, and so Same idea here. Okay, this is a linear relationship. All right. So let's do some practice with that here. So we're going to write an equation for the nth term and find the 20th term. There we go. Okay, so we're going to write an equation for the nth term and find the 20th term using our given information here. Okay, so first one here, we're going to say a sub 1 equals 5. And we'll say that D, the common difference, is 4 again. All right, not very exciting. We just had a common 4, but there it is. And this means that our pattern is going to start with 5, and then our next number in that pattern or in that sequence will be what? 9. That's right. And then 13, and then 17, and then, well, you get the idea. So what will our pattern, or sorry, what will our formula then look like here, CC? If I start with a sub n equals a sub 1 plus n, minus 1 times d. Okay. What can we fill in here to our formula to help us find that 20th term? Equals, sorry, what? Sorry? A sub n, right, so a sub n, we want to find the 20th term. So we'll actually say, a sub 20. We're going to find the 20th term. So it'll be 5 plus, and then 20 minus 1, right, because n is 20. And then, yeah, times 4. Okay? So there it is. Yep. All right, I found that 20th term there. And so let's see here. 20 minus 1 is 19. Times 4 is going to be 76. Plus 5 will be 81. Okay. I guess I also need to finish writing the equation here, because we kind of like wrote the equation, but we need to write it in for this situation. So there's our answer for the 20th term. But then I guess also our formula should be like a sub n, in this case, is going to be 5 plus n minus 1 times 4. So that's like our other piece there. There's the equation, and then there's the answer. Okay. And again, if you want to, you can distribute the 4 there, combine like terms and all that good stuff. That's fine. Or you can just leave it unsimplified and just do it that way too. Okay. Questions on any of that? All right. Then number 2 here. I'm going to have you guys try and figure this one out. We have a sub 1 equals 5. And a sub 5 equals 16. Okay? So go ahead, come up with an equation for the nth term, and then also find the 20th term using just that information there. Okay? So see what you can come up with from that. Oh, I'm sorry. I got the wrong. It shouldn't be 5. That's right. That's wrong. It'd be negative 4. My mistake. I was reading the wrong thing. Okay. First term is negative 4. Okay, and then you want to go up to 16. My mistake. I apologize. So there you go. That will make it a little bit easier, I think, too, because 5 would have been a little tricky. Yeah. Okay. Yeah. Just negative 4 to 16 there. Again. Yes. Write the equation for it and try and solve for the 20th term. Yes. No, you can figure it out without having to do it again. No, you don't have to write it out. I just do it just to kind of help me get my bearings, but you don't need to know. And for others to kind of help them get their bearings too. That would be your 5th term, yes. So you can plug A, say 16 equals that thing. Yes, so then find the 20th, don't forget to find the 20th term. I want you to, yes, that's correct. So find the 20th term. Okay, so let's see here. So you're saying the common difference is this? Oh, it's negative 4 was the first term, not 4. So it would be right if that was the first term, yeah. And then don't forget to find the 20th term again, then once you do that. Okay, yeah, that's right. So what's the common? Yes. Yes. So the common difference would be 5, and so then make sure you find in the 20th term as well. John, you get it figured out, yes? Not quite, okay. So, yeah, it would be, if you're trying to do it this way, the 16 would go here, the 5 would go here, because that's the n. N is 5. You see what I'm saying? And then you can solve from that way if you want to. Okay. All right, like 30 more seconds here, and then we'll continue on. Okay, so here's what we should end up with. Okay, 91 is the 20th term. 91 is the 20th term, and then there's our formula. A sub n equals negative 4 plus n minus 1 times 5. Now, the way I figure out the common difference here is I actually just like kind of wrote it out. I was like, okay, we had negative 4 and then the fifth term had to be 16, so I had -4, blank for the second term, blank for the third term, blank for the fourth term, and then 16 for the fifth term. And I was like, okay, we have to add by the same amount each time, so I just called that x. There's 4 of them to get there, so 4x equals, and then the difference here, 16 minus -4 to get the 20, and so x is 5. That's one way to do it. Alternatively, though, don't forget we have this formula here to help us, right? So if we have that the fifth term is 16, that means I can say a sub 5 equals, and I have my first term too, -4, equals -4 plus my n is 5, and then I'm going to solve for the common difference. I know that a sub 5 is 16 here, so I could put the 16 in place of that a sub 5. I guess I'll go ahead and just do the subtraction there. You see? Okay, so we just plug in what we know to our formula and solve for the common difference d. So we add the 4 over, we get 20 equals 4 times d, and then divide both sides by 4, we get d is 5. And so that's another way you can find a common difference too, is just to use that point. Just to use that point. The fifth term is 16. It won't really help us if you try and plug in the first term, because the first term would be 1 minus 1, which would be 0, which will completely cancel out the common difference, so that's not helpful. But if you have that other point, the fifth term in this case, you can use it to help find that common difference without having to, worry about like writing out all these blanks and figuring out that stuff. Okay, that's another way to do it. Questions on any of that? Feeling pretty good? All right, so that's arithmetic sequences. Now we'll look at geometric sequences. Okay. Again, this formula you will not need to memorize. So a geometric sequence is a sequence of numbers where the ratio between consecutive terms is the same. Sequence of numbers where the ratio between consecutive terms is, excuse me, the same. So for example, let's say I've got like 3, 6, excuse me, 12, 24, 48, ... Okay. The ratio here, okay, between consecutive terms. So you take the second term and put it over the third. So 6 divided by 3, 2. All right. 12 divided by 6, 2. 24 divided by 12, 2. 48 divided by 24, 2. So this is called the common ratio. 2. Okay. Or in other words, it's a sub n plus 1 over a sub n, if you want to think of it that way. A sub n plus 1 over a sub n. Okay. Sometimes, or in other words, it's the number you multiply by each time. Right? In arithmetic sequences, it was the number you add each time. In this case, it's the number you multiply by each time. Common ratio. Okay. The formula to find the nth term here is, again, a sub n, that common, symbol we use to represent the nth term of a sequence, equals a sub 1, the first term, times the common ratio to the n minus 1 power. Okay, so that again, nth term, first term, common ratio, and then just the number of the term. So in this particular case, so from this example here, okay, Our first term is 3, so just put 3 times common ratio. Well, it's 2, right? We said there was 2. So 2 to the n minus 1 power. What's that? So there's a generic formula for any term. If we want to find, for example, the third term in this sequence, right? The third term will be 3 minus 1, 2. 2 squared is 4. 4 times 3 is 12. And there's third term, 12. Works. Questions on any of that? Okay. So again, like things we could be asked to do here. We could be asked to, write out the first 5 terms of the sequence given a sub 1, equals 2, and r equals, 5, for example. Route the first 5 terms of the sequence, given a sub 1 is 2, and r equals 5. So that means we would start with 2 here. And what would our next term be? And it's the geometric sequence, right? So our first term is 2. What would the next one be? What's that? 10, right? Yes, 10. Multiply by 5, right? Times 5, so that'd be 10. The next one will be 50. And then 250. And then 1,250. And luckily we can stop there. Okay. That's the idea. All right. Let's see here. How about, again, you guys try one here. Find the 15th term. Whose first term is 20. Or actually, let's do this. Find the 15th term given a sub 1 equals 20 and r equals 1.05. Okay, and you may use your calculators for this if you wish. Right? You may use your calculators for this one if you wish. So find the 15th term given that a sub 1 is 20 and r equals 1.05. And again, just round your answer to 3 decimal places. So hopefully we got approximately 39.599. All right, questions on any of that? All good? No questions? Okay, so again, using the formula, and you'll be given the formula, so that's nice, but you do need to know how to use it, okay? You do need to know how to use it. All right, so the next thing here that I want to kind of talk about are series, okay? And this makes it even trickier because we just talked about sequences. They both start with S. They both sound similar, okay? And they are kind of similar, but we have to differentiate the two. A sequence is just a list of numbers. They're separated by commas, okay? A series that is a sum of a list of numbers, okay? That is the sum of a list of numbers, okay? So it's like taking that, taking a certain number of terms and adding those numbers up. Okay? And so there's a famous, I'll get to that in a second here. There's some notation we also need to be aware of, too, when it comes to adding up a bunch of numbers, okay? And it's called sigma notation. So, for example, I could just write a sub 1 plus a sub 2 plus a sub 3 plus a sub 4 plus, dot, 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 up until, like, I don't know, a sub n. Or like we had this, so this is like a series, whereas we might have had a sequence of those same numbers, a1, comma, a2, comma, a3, comma, a sub 4, comma, a sub n, right? So we just talked about sequences. We had terms, right, in a list, but now the series takes those terms and adds them up until whatever that nth term is. Okay? That's a lot to write out. And so we use symbols to help us kind of describe a series. And the way we describe a series is this. So this is equivalently described as, anyone know what that Greek letter is there? So sigma, okay, sigma. So sigma stands for sum. Okay, I think it's a capital sigma. Okay. And we're summing up a sub n's. Okay, so we're going to sum up a bunch of terms, a sub n's. But of course, or sorry, I should say, this is not a sub n's. We're going to sum up a sub I. My mistake. I apologize. There should be a sub I. Forgot. So we're going to bunch of a sub I, and the way we know how many of those to sum up, we start with I equal to 1, right? So we start with our first term. So we're summing from I equals 1 up to I equals n. Sometimes we just put an n up there. I guess I don't need to put another I. I just see the n. My mistake. Sorry. So the n up there on the top. So sums from 1 to n, from the first term up to the nth term there. Okay. That's how we can write that. So for example, if I wanted to sum up, like 1 plus 2 plus 3 plus 4 up to 10, if I wanted to add up like 1 through 10, for example, I would start with I equal to 1 down here, and it'll sum up to 10, and then I would just put I there. That's it. That's equal to 1 plus 2 plus 3 plus 4 plus dot 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 plus 9 plus 10. You get the idea. I know I'm lazy for not wanting to write those all out. That's what that would mean. Okay? You kind of count up from 1 to 10. I counts up from 1 to 10. So I is always going to be a whole number, I guess, there. So it goes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Counting those up. Okay? So that's some notation we want to be comfortable with here, too, to see kind of what, the different things we're adding up and stuff there. Okay. And there's a famous story about how the idea of series was developed or whatever. So like one famous one is that there's a mathematician named Gauss, and when he was like in school, his teacher, I guess, wanted to give the students some work to do that would take some time, and they thought was going to take some time. And so the teacher asked the students to do this: take the numbers from 1 to 100 and add them up. So in other words, the teacher was like, all right, everyone go ahead and find the sum of the numbers from 1 to 100, right? And so of course most students went about, starting to add, okay, 1 plus 2 is 3, plus 3 is 6, plus 4 is 10, plus 5 is 15, and then keep, adding and adding and adding, and they just kept going and adding it all up, all right? And so it's taking some time. Gauss, who again, famous mathematician, brilliant guy, died early on from tragic reasons or something like that, okay? He was able to finish it in a very short amount of time because he did something kind of clever here to add this up. Rather than taking this, okay, and adding it up like from left to right, he kind of like doubled it and wrote it backwards. Oops, 90, shoot. Yeah, that was right. 100 plus 99 plus 98 plus, and then down to here. Okay, so he basically reversed it. And so the result is that if you add these together here, 1 plus 100 is 101, 2 plus 99 is 101, 3 plus 98 is 101, 4 plus 97 would be 101, 98 plus 3 is another 101, 99 plus 2 is another 101, 100 plus 1 is another 101. And so how many of those 101s do you have? If we're counting up from 1 to 100, how many will you have? We'll have 100 of them. So it's going to be 100 times 101. But of course we doubled it, right? Because we took one list and we added the same numbers again. So we doubled the quantity there. So we have to divide by 2. And so it's going to be 50 times 101, which is 5,050. That's the sum of all the numbers from 1 to 100. Okay, so he did that real quick. Again, that's a myth, a legend maybe. I don't know if it's actually true, but it's still a fun little story. And clever, right? Clever. And that's a lot of what mathematics is once you get beyond a certain point. I know you guys aren't really used to that. We don't do a very good job of, kind of cultivating that within you here in school, and that's why math can seem really boring to a lot of you too. But a lot of math is creativity and coming up with unique ways and more efficient ways to do things, and not just number crunching all the time, but really kind of thinking about things in a different kind of way, so you can come up with alternative ways to solve things that are maybe better or faster or more elegant kind of thing. So anyway, that's the idea there. So in our terms then, how can we use this? Well, for an arithmetic series, okay, that is when you're adding the same number each time in the sequence, the sum of an arithmetic series is equal to the number of terms that you're adding up divided by 2 times the first term plus the nth term. Okay, so again, S stands for the sum. Okay, N is the number of terms that you're adding up. Okay, A sub 1 is the first term, which is the a carryover from talking about sequences, and A sub n is the nth term, again a carryover from the sequences stuff. So as an example here, I'm going to squeeze it over here. And again, this formula, you won't have to have memorized. It'll be given to you. You need to know how to use it, what it means, okay? But it will be given to you, okay? So let's say, for example, that we are given the sequence a sub n equals 2n minus 6. And we want to find the sum of the first 150 terms. So given the sequence, a sub n equals 2n minus 6, find the sum of the first 150 terms. Okay. So, all right, the sequence is not given to us as a list of numbers, it's given to us as the formula. So that's kind of weird. So what might be helpful here is to kind of take this sequence and write it out as the actual list of numbers. So in other words, the first term, a sub 1, it'll be 2 times 1, 2 minus 6, so it's negative 4. Okay, a sub 2, right, so we plug 2 in here, 2 times 4 is, 2 times 2, sorry, is 4, minus 6 is negative 2. A sub 3, so 3 times 2 is 6, minus 6 will give us 0. And so you can kind of see, okay, here's the sequence. And we want to add these numbers up to the 150th term. Okay, so does that make sense there? That's what we want to do. So if we go to use our formula here, well, let's see, we've got S equals N. So what is N in this case? What's our number of terms? 150. So it'll be 150 over 2 times, what's A sub N? Sorry, what's A sub 1? What's our first term? Yeah, negative 4, right? It's given to us. Negative 4, very good. Yeah. Plus, now we have to find, well, we don't want the nth term, we want the 150th term. So I have to go like, we got to figure out here what's the 150th term. How can we do that without having to continually add our common difference of 2 here each time? How can we figure out that 150th term in the sequence? We go back to our old formula. Whoops, that's the right paper. Okay. We go back to our old formula here of the nth term. Okay. And now I don't know where I put that paper. That's okay. Okay. We go back to our old formula. And so we're going to use a sub 150 equals a sub 1 plus n minus 1 times the common difference. Okay, well, I guess I should have said 150 in there. So a sub 150 equals negative 4 plus 150 minus 1 times the common difference of 2. Right, we're adding 2 each time. I'll zoom in on this. There we go. Okay. Oops. And so we get, if we do this math here, we're going to get 294. Okay, 294 here. So the 150th term is 294. Okay, so we had to solve. We had to solve for that. And now you can just type into our calculator. Okay, we get 21,750. And that is the sum of those first 150 numbers in this pattern. So it's negative 4 plus negative 2 plus 0 plus 2 plus 4 plus 6 plus 8 plus 10 plus 12 plus up to 294. You're going to add those all up. Okay. An alternative way to ask this question. So another way you could see it is using that sigma notation. Another way of asking this is to see the sum from 1 to 150 of 2I minus 6. That's also equal to that same thing there. The sum from 1 to 150 of 2I minus 6. Right, so you imagine I plug the 1 in there, 1 times 2 is 2, minus 6 is negative 4, plus, and then I'll count up to 2. 2 times 2 is 4, minus 6 is negative 2, plus, and I count to 3 for the I. 2 times 3 is 6, minus 6 is 0, plus, dot, dot, dot. And you get the idea there. So that's the way to see it in sigma notation. Sigma notation. Okay. We'll do one more of these, and then we'll move on to geometric series because I want to make sure I get everything in. Okay, so one more arithmetic here. So let's just calculate the sum of the first 50 terms of 0.2, 0.4, 0.6, so we're finding the sum of that, the sum. Okay, and we can see here that we're adding by the same amount each time, right? We go up plus 0.2, up plus 0.2. So it's an arithmetic sequence, but we're going to add it up, so it's an arithmetic series. We're going to use the sum formula here. S equals n over 2 times a sub 1 plus a sub n. In this case, right, what is our n? What's the number of terms? 50, yeah. So it'll be S equals 50 over 2 times, what's a sub 1? What's our first term? Our first term, our first term is 0.2. Okay, plus our nth term. We don't know that. So again, we have to go back to that formula up here that we had, right? So we want to find we have to find that 50th term. So it'll be a sub 50 equals 0.2 plus 50 minus 1 times the common difference of 0.2. We get 10. Okay, so the 50th term is 10. And so now we can just simplify that math there. We got all of our information. So it'll be 25 times 0.2 plus 10. So 255. So again, that 255, that's 0.2 plus 0.4 plus 0.6 plus 0.8 plus 1 plus 1.2 plus 1.4 plus 1.6, so on and so forth. So this is our final answer right there. Questions so far? All right, thank you guys for hanging in there with me here. We're nearing the end, all right. So let's look at geometric series then. Okay, and we have two geometric formulas for us, interestingly or not so interestingly enough, on a Friday at the end of a full week here. All right, we have a formula for finite geometric series. Okay, so that's where we're adding up a geometric sequence. Okay, and that is the sum equals a sub 1 times 1 minus r to the n over 1 minus r. Again, you won't have to have that memorized, so you will be given that. You just need to know how to use it. So again, that stands for the sum. That's the first term. And then r is the common ratio. And then n is the number of the term, or number of terms, I should say, that you're adding up. Okay, and so for our first example of this, I'm going to change it up on us. I'm going to put it in sigma notation. And that's all it is. So we'll just, our directions will say is just evaluate. Okay. So how many terms are we talking about in this particular series? How many terms are we talking about? How many will there be? If I were to write it out, how many would there be? 8, right? We're counting from 1 up to 8, so that's 8 terms. And you could, actually, this one's not that awful, you know, so if you were like on the test and you were like panicked and you're like, I don't even know what to do, I mean, you could, if you wanted to, write out all 8 terms and just use your calculator and add them up. So you put 0.3 to the 1, you know, plus 0.3 squared, plus 0.3 to the 3rd, plus 0.3 to the 7th, plus 0.3 to the 8th. And you could just literally just do that. That's not that awful, right? Because there's only 8 of them. It wouldn't take forever. All right. But that's how we could write it out. But of course, we don't want to do that. We want to use our formula here. So sum. And of course, if you're confused about this, write out the first few couple terms to kind of help you get your bearings about what's happening here. Okay. Remember, we're counting up from 1 to 8. So we start at the 1, then we count up to 2, then to 3, and those ends are just, the numbers here are just going in for the end there. So it's, you know, 1, 2, 3, dot, 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 up to 7, and then 8 to finish it off. We stop at the 8. Okay. So anyway, our first term here is 0.3. Common ratio. Well, what is the number that we're multiplying by each time to get our next number in the pattern there? What is it? 0.3, right? We're multiplying by another 0.3. So our common ratio here is 0.3. To the n, how many terms are we talking about again? 8. So 0.3 to the 8 over 1 minus 0.3. Okay, so there's your setup, and so you just simplify that. You know, if you want, you can kind of take it a piece at a time, do the numerator first, right, and then divide by that denominator. Make sure you put parentheses around the numerator and denominator so it doesn't, you know, it doesn't miscalculate here. So, I get a decimal of approximately 0.429. Okay. Just as another quick example here, I'm not going to get you the whole way through it, but just again so you can kind of get a feel a little bit more for these. Just so you can get a feel a bit more for these like sigma notation problems. Okay, again, when you look at this, it might not be obvious that this is a geometric series, right? You might be like, well, is it geometric? Is it arithmetic? What am I doing? We know it's a series because we're summing, but what is it? Again, if you're unfamiliar, write out the first couple of terms to help you out. So the first term is going to be 4 times 3 to the 1 minus 1. Plus, the next one now n will be 2, so it'll be 4 times 3 to the 2 minus 1, plus 4 times 3 to the 3 minus 1, and then, you know, you kind of get the idea from there. The only number that's changing is the n. Okay, and so this is really just 4, well, 3 to the 0 is just 1, so it's just 4 for the first one. 3 to the 2 minus 1, that's 3 to the 1, so it's 4 times 3, 12. 3 to the 3 minus 1, that is 3 squared, so it's 9 times 4 is 36, and then you can kind of see there. So to get from 4 to 12, to get from 12 to 36, what are we doing each time here? What are we doing? Multiply by 3, exactly right. So this is a geometric series. Our first term is 4, our common ratio is 3, and again, we would have add up the first 12 terms there. Okay? All right, last formula here. The infinite geometric series. In certain cases, you can add up an infinite number of things, and you will get a single number value. Okay? You can add up an infinite number of things and get an actual value. All right, it won't go to infinity. And so here's the formula. The sum equals a sub 1 over 1 minus r. But here's the exception. This is only true when the absolute value of r is less than 1. Otherwise, the sum does not exist. It goes to infinity. Okay, so there's our last formula there. Infinite geometric series. Okay, so I'll just do one example here, and then we'll be done. We're going to find the sum of the following series. Okay, so 500 plus 300 plus 180 plus, and notice I'm not saying a certain number of terms here. I'm saying it just keeps going. Add these all up. An infinite number of numbers, add them all up. It will equal a single value. Okay? So first of all, if we look here, we have to figure out, well, what is our common ratio? What do we multiply 500 by to get 300? What do we multiply 300 by to get 180? Well, remember, you can take that second term, the 300, and divide by 500, and that simplifies to 3/5. And if we do that same thing to the 180 over the 300, it also simplifies to 3/5. So our common ratio here is 3/5. So the sum will be 500 over 1 minus 3/5. Okay, which if you do that in your calculator here, okay, 1,250. Okay, so adding up an infinite number of things in this situation yields a sum of 1,250. Okay, so there it is. If you see it in sigma notation, it'll start n equals 1, and then it'll have a little infinity up there. It means you're adding up an infinite number of things. So, for example, like this might be a way you see that. Okay, but again, write out the first few terms to help you out. Okay. Phew! So, I would put the, actually I got you guys your review sheets too, so let me do that.